We're going to look at how to solve polynomial equations by factoring. The first thing that we need to know is called the zero product principle. So let's take a look at that. The zero product principle says that if you have two things being multiplied, let's say A times B, and they multiply to equal 0, then either A or B must be equal to 0. So then the solution to A times B equals 0 is that A is 0 or B is 0. So we can apply that to something that has been factored. So let's say I have like this, x minus 3 times x plus 1. And let's say that that equals 0. We can actually find the solution to this by setting x minus 3 equals 0 and adding the 3 over so we get x equals 3, or taking x plus 1 equals 0, subtracting the 1 over, and we get x equals negative 1. So the solution to that would be 3, negative 1. Right, so if we have any polynomial that we can factor, we can find the solutions by setting each of their factors equal to 0 and then solving for that factor. Let's look at some examples of this principle. Before we look at any more examples, let's go over the steps for the process of solving a polynomial by factoring. So let's take a look here. Step 1 will be to determine the degree of the polynomial. So this will tell you the maximum number of solutions that the polynomial will have. To determine the degree of the polynomial, you look at the highest power on your x variable. So if you have 3 different powers, like an x cubed, an x squared, and just maybe an x to the first, then the degree of the polynomial will be the highest of those 3, which would be x cubed. If your polynomial is x cubed, then that means you would have at most 3 solutions. If your polynomial is x squared, then you would have 2 solutions, and so forth. So step 2 is really a setup step. So you want to set the polynomial equal to 0. So if there are different pieces of the polynomial on either side of the equation, make sure you bring everything over to one side and then have that equal 0 on the other side. It doesn't matter which side you bring the equation or the pieces over on the equation, but what I like to do is not have negatives. So I take my highest power and I want that to be positive. And then, so if it's a negative on one side, I'll bring it over to the other to make it positive. If it's already positive, I will bring everything over to that side. I want my powers to be written in decreasing order. So once again, if I have an x cubed, an x squared, and then an x, I will want to make sure that my highest power is first, then my second highest, and then my lowest. And keep doing that until you have the powers in decreasing order. Alright, step 3, it's simple factor, but it's actually the hardest step of the process. So you'll have to think of different ways that you can actually factor the polynomial. You may have to factor one term out first and then factor it like a trinomial. You may need to factor by grouping. There are lots of different ways that you can factor, and so we'll look at a bunch of examples so you can see them. The last step is just to set each factor equal to 0. Once again, we'll use the zero product principle, and then we will solve each factor for the variable. These solutions are the solutions to the polynomial. So, like we saw before on the first little example that I did, you took each factor, set them equal to 0, solve for the variable in each factor, and those are the actual solutions. Now you can go and check to see if your solutions work back into the original equation. That will be a good way to tell if you've got the right answers or not. So let's look at a bunch of examples on how to actually do this. The next equation is 5x squared equals 6 minus 7x. So the first step that we need to do is determine the highest power. In this case, we have x squared, so the degree of this is 2, which means we can have at most 2 solutions. The next step is to bring everything over to one side. I do have 5x squared here and then equals 7 or x minus 7x. Because this is already positive, let's bring all of that over. So we have here, let's subtract the 6 and add the 7x. And we'll bring those over here. So I end up with 5x squared plus 7x minus 6. So that is actually going to equal 0. Now we want to first look for a common factor, and there is none. So then the second thing we will do is let's multiply the 5 there. We get x squared plus 7x minus 30 equals 0. Okay, let's think of the factors of 30 that get us to 7. Now, they have to be opposite signs, remember, because we have a negative 30, and the bigger number is going to be positive. Alright, so the factors then of 30 would be 3 and 10, because the difference of 3 and 10 is 7. 10 is the bigger number, so it's the one that gets to be positive. Alright, and because I did multiply by 5 here, I need to make sure I go back through and divide by that 5. So we end up with x plus 2 and x minus 3 fifths. So that means that my solution is when x plus 2 equals 0, so x equals negative 2. And then also when x minus 3 fifths equals 0. So that means when x equals 3 fifths. So there we go. There is the solution to our there's the solution to our polynomial equation. So this one is a little different. If you notice, its highest degree is not 2 anymore, it is 4. So that means we can have at most 4 solutions. So what we have to do first is factor any common factors. So you notice that between these two, they both have a factor of 3, and they both have a factor of x squared. So let's factor out 3x squared from both of those. Whoops, let's see. So we have 3x squared. What we're left with on this side is just x squared. And what we have here is 16. Now that kind of, you'll recognize that from the last problem, hopefully. We can factor it even farther. Don't forget about the 3x squared. That will be important. But if we have the factors of x squared minus 16, that's the difference of the squares. So we have x minus 4, x plus 4. Okay. If you were to go through and multiply all the x's, you would have x squared times x, it's x to the 4th, and that's what you should have. You need to keep that high power. Alright, so we're going to take each of these factors. We're going to take 3x squared. We're going to take x minus 4 and set all of them equal to 0. I forgot about writing that. And we have x plus 4 equals 0. So when is 3x squared equal to 0? Well, the only thing that x can be would be 0. When is x minus 4 equal to 0? When x equals 4. And when is x plus 4 equal to 0? When x equals negative 4. So our solutions here would be 0, 4, and negative 4. Alright, this last example is pretty unique, so let's take a look at it. The highest degree first is to the third power, so our degree is 3, which means we have at most 3 solutions. Now it doesn't mean we have to have 3 solutions, but here we will. So we have to first factor, but we don't really have a way to factor when there's more than 3 numbers in terms of factoring into the trinomial. So what we have to do is we have to factor by grouping. So I'm going to group the first 2 numbers together and then the second 2 parts together. And look, between each group there's a common factor. I have x squared, so the first one I'm going to factor the x squared out. And that leaves me with x cubed. Factor x squared out leaves me with x. Factor an x squared out there on the second number and we get an x plus 2. Alright, the second group here I'm going to factor out, they both have a negative 9. So I'm going to factor a negative 9 out from this. I have then x, and if I go negative 18 divided by negative 9, we should get plus 2. So that's a little different, but it's the same concept as factoring when there's a common factor between each pair. Now, that same idea, with here I have an x plus 2 and an x plus 2. So I'm going to factor from each of the groups. I'm going to factor that whole x plus 2 out from each thing. And what I'm left with here is this x squared, and what I'm left from here is the minus 9. Right, and then some more factoring. It's a factoring problem. Okay, we have x squared minus 9. We're going to go x plus 3 and x minus 3. And we have our polynomial completely factored. Notice I do have 3 factors, which would give me my 3 solutions. So what makes x plus 2 equal to 0? I subtract that 2 over, it's negative 2. What makes x plus 3 equal to 0? Subtract that 3 over, it would be negative 3. And what makes x minus 3 equal to 0? That's positive 3. You've probably noticed this throughout doing all of these problems, but it's always the opposite sign of what is inside your factor. So if it's x plus 2, then negative 2 is your actual factor. And those are our solutions to that factoring by grouping. Alright, that is it for this video.